So we're on page 137, and you were told to try number 3. And the directions in number 3 say, use the rational root theorem to find the possible real zeros and the factor theorem to find the zeros. Let me remind you why we have to do this. Because we can't factor this. We don't know how to factor 5 terms, and there's no GCF to take out to make this any less. So we have to use the rational root theorem because this is not factorable from what we know how to do. Okay, so we are going to start with our P and our Q. P is our constant. Our constant is 8. So we are going to write all of our factors down for P. So all of the factors that multiply to get 8 are 1, 2, 4, and 8. And don't forget that these are plus or minus values the whole time. Then we have to look at our Q value. And our Q value is our coefficient in our lead term, which in this case is 1. So our P is 8, and our Q is just plus or minus 1. How glorious that we will be able to do this without a problem, because we know that these divided by 1 will just give us these at the end anyway. So when we do P divided by Q, in this case, we are going to end up with plus or minus 1, plus or minus 2, plus or minus 4, or plus or minus 8. Now our job is to actually go ahead and plug these in. So in case you are confused at this step, because I keep coming back and having it all filled in, I'm going to fill in the first one, then I'll pause, do the rest, and then come back and we'll talk about it. What we're doing is we're plugging each of these potential roots into this function equation. So wherever I see an x, I'm going to plug in. The first one that I want to test is 1. So I'm going to plug 1 into this to figure out what the value is. Our goal is to have a remainder of 0. So if we end up with 0 as an answer, that means that it's a solution. Anything other than 0 is not a solution. So plugging 1 into this function is 1 to the 4th plus 1 to the 3rd minus 6 times 1 squared minus 4 times 1 plus 8. So we're going to calculate this. We're going to come up with a value and see what it turns into. This is 1 plus 1, which is 2. This, don't forget, you got to square before you multiply. So this is 1 squared is 1, then minus 6. So we have 2 minus 6 is negative 4, plus another negative 4 is negative 8, and negative 8 plus 8. Oh, there's our first answer right there. Boom. And I didn't even know that was going to happen. See that? That's amazing. Here's a solution. We know it's a solution because the outcome is 0. That means there's no remainder, and that means it's a factor. Okay, that's factor theorem. So this is a solution. Our solution is literally x equals 1. That's an answer. That's a spot where if we go to sketch this, this is going to have a place on our graph. Now I'm going to pause this, and when I come back, the rest of these will be tried, and we'll figure out what the solutions are. All right, just want to give you an update. I wrote all of the function out with every single substitution for every single option, and I'm going to go ahead and figure out what my which ones are solutions and which ones have remainders. I'll be back. Okay, I'm done. Check it out. And here's the thing. This has a degree of 4, which means that we can have at most 4 solutions. So as you get to filling these in, you have to keep going and test all of them to see if there's any more real ones. And the fact of the matter is that in this case, we have 3 real roots, which means that one of these has to be a double again. But without doing our next method, we're not going to be able to figure out which one is the double. So what I'd like to do now is I'd like to do a little transition, and then we will start synthetic division, and then I can show you an easier and more efficient way of doing this. But you still have to do rational roots theorem to start the problems. They just don't need all this work. So hang tight and enjoy your transition, and I'll see you in a minute.